Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for May-June 2022, and the code is 9709/62. So let's move on to question number 1. Question number 1A. A javelin thrower noted the length of a random sample of 50 of her throws. The sample mean was 72.3 meters and an unbiased estimate of the population variance was 64.3 meters squared. Find a 92% confidence interval for the population mean length of throws by this athlete. Okay, so now 92% confidence interval for mu. Mu is a population mean. The formula is x bar plus minus z s over square root n. Okay, so now here the sample mean, this is basically the x bar. And then the unbiased estimates of variance, this is basically sigma square hat, which is our s squared, the sample standard deviation, and you were given 64.3. Okay, now I need to know what is the z value when it is 92%. Therefore, we have to sketch a normal graph. Middle is 0. So 92% is the region bounded in the middle. Okay, so here is 0.92. Now, for your information, to use a normal table, we need to know what is the total area towards the left-hand side. I know that total region below the graph is 1, right? So it will be 1 minus 0.92. I will get 0.08. But there are two parts here, left and right side. Then you have to divide by 2. So it will be 0.04 for each left and right side. Then now 0.04 plus with 0.92, it will be 0.96. Okay, so now I need to find what is the value from the table when it is 0.96. So you will find that it is 1.751. Here is negative 1.751. Then this is our z value. Okay, the critical value. So now just replace all the values. Your x bar is 72.3 plus minus the critical value is 1.751. This s is the sample standard deviation, which means we need to get s from the s squared. Then I have to take square root of this value. Okay, so since I need to take square root, then I will combine with the denominator. So it means it will be square root of 64.3 over the n is 50. Okay, so now the lower limits can be found by using the minus sign. Then you will get 70.3, correct to 3 significant figures, and the other one is 74.3. So this is the confidence interval for population mean length. Okay, now B, discuss thrower wishes to calculate 92% confidence interval for the population mean length of his throws. He bases his calculation on his first 50 throws in a week. Comment on this method. Alright, so you refer to the calculations on his first 50 throws in a week. So that means this is not a random sample. Alright, so I will just write it is not a random sample. Okay. So now question number 2. In the past, the mean height of plants of a particular species has been 2.3 meters. This is a mean height. A random sample of 60 plants of this species was treated with fertilizer, and the mean height of these 60 plants was found to be 2.4 meters. Assume that the standard deviation of the plants, of the height of the plants treated with fertilizer is 0.4 meters. This is a standard deviation. Carry out a test at 2.5% significant level of whether or not of whether the mean height treated with fertilizer is greater than 2.3 meters. So from here, your H0 is mu equals to 2.3 meters. Then the H1, the alternative hypothesis, it will be greater than 2.3. So mu greater than 2.3. Okay, and then based on the last paragraph, the alpha is 2.5%. That means your alpha is 0.025. Okay, so from here, when you look at the first paragraph, right, then you are given the standard deviation is 0.4. Okay, and then the n is large 60. Therefore, we are using normal graph. The z-test, I would say we are using z-test. So now I draw the graph, and this is 0. Now, by looking at the H1, since this is upper tail test, therefore your region is on the right side. Okay, the area of this region is going to be 0.025. Now, since we have decided to use the z-test, that means I need to know the region towards the left hand side here. So region on the right side is 0.025. Region towards the left hand side is going to be 1 minus 0.025, which is 0.975. Okay, and then the normal table will give you the critical value of 1.96. Alright, so with this I can write down my rejection region, which is reject H0 if the z value is greater than 1.96, which is a shaded region. Okay, now for my calculation, so I will write z equals to x bar minus mu over sigma over square root n. Okay, sigma is the population standard deviation. So from here, the mean height of 60 plants is 2.4. That means here I'm going to get 2.4 minus this mu is the mu at the H0. So at the H0 it is 2.3. So minus 2.3 over the sigma is the population standard deviation, which is 0.4. Then divided by the n is a sample size. Here is 60. Okay, this is a calculation. Then you will get 1.94, correct to 3 significant figures. Now, I will mark this value 1.94 on the diagram. So obviously 1.94 is before 1.96, which is outside the region. Okay, so I will write z less than 1.96. Therefore, you can write do not reject H0 or accept H0, right? Up to you. So here I will just write do not reject H0. Okay, because we reject H0 when it is greater than 1.96. So now your conclusion, whether or not it is greater than 2.3 meters. So now we do not reject H0, means that there is not sufficient evidence to conclude this is greater than 2.3 meters. Alright, so I will just write there is insufficient evidence to conclude that the mean height just copy from here of plants treated with fertilizer is greater than that. Okay, so that's the decision and conclusion for this hypothesis testing. Okay, now, question number 3. It is known that 1.8% of children in a certain country have not been vaccinated against measles. A random sample of 200 children in this country is chosen. A. Use a suitable approximating distribution to find the probability that there are fewer than 3 children in this sample who have not vaccinated, right? So from here, Our n is 200, so x is binomial 200. Not vaccinated is 1.8%. 1.8% is basically 0.018. So this is our n, this is our p. Alright? So since your n is large and is given that the hint use a suitable approximating distribution, that means now I have to calculate what is my NP. So now my NP is 200 times 0.018, and then you will get 3.6. Alright, so from here I know that when the n is greater than 50 and the NP is less than 5, that means this is going to use Poisson approximation. Okay, so for Poisson approximation we need the mean. So the mean is basically the NP, which is 3.6. Then from here I will write my y is Poisson 3.6. Okay, then now you need to count the probability that's less than 3 children. So P, Y less than 3. So when less than 3 means that it starts from 0, then continue until 2. Okay, so for your information, if the x is Poisson distributed with mean lambda, the probability of x equals to e negative lambda degree x over x factorial. So basically the e negative lambda is a constant. So for the calculation, I will factorize e negative 3.6 because my 3.6 is the lambda. Then now y equals to 0 means the x value here is 0. So any value any number with the power of 0 is 1. Then over 0 factorial, okay, when I replace the x by 0, 0 factorial is also 1. That means the first value is going to be 1, then plus, then 3.6 to the power of 1 over 1 factorial. Then you can just write 3.6. Basically, you can just write 3.6. Then for the next one, it's going to be 3.6 squared over 2 factorial. Okay, so when you calculate this, it will be 0.303. So that is the probability of this question. Now B, justify your approximating distribution. So simple, because n is greater than 50 and then NP is less than 5. Okay, so I have shown here your NP is 3.6, which is less than 5. Therefore, we are using Poisson approximation. Okay, now for question number 4. The number of cars arriving at a certain route junction on a weekday morning has a Poisson distribution with mean 4.6 per minute. Traffic lights are installed at the junction and the council officer wishes to test at 2% significant level whether there are now fewer cars arriving. He notes the number of cars arriving during a randomly chosen 2 minutes period. This 4.6 is per minute. Okay, but then now we refer to 2 minutes period. Now, state suitable null and alternative hypothesis for the test. So now, 4.6 for 1 minute. So if 2 minutes, it will be times 2. Then I will get 9.2. Therefore, my null hypothesis, the lambda equals to 9.2. And then the H1, which is the alternative hypothesis, lambda will be less than 9.2 because he is expecting fewer cars arriving. Okay. Now B, find the critical region for the test. So we know that X is Poisson with lambda 9.2. Now the alpha is 2%, right? So 2% means that it will be 0.02. So remember, this alpha is the probability for you to reject H0. Okay, basically from the alpha, you will know that our rejection criteria is going to be reject H0 if Px less equals to small a less than 0.02. So now I need to find what is my a here. So my a, x less equals to a is my critical region. Okay, so now I start with Px less equals to 2. So when Px less equals to 2, now since this is Poisson, use back the same formula as just now X is Poisson distributed, PO, okay, 9.2, then Px equals to small x, it will be E minus lambda, lambda x over x factorial. So here I better write PO, right? Poisson distributed. Okay, now, here I will get E negative 9.2, which is a constant. When less equals to 2, okay, let's say I show step by step. Less equals to 2 means that Px equals to 0 plus Px equals to 1 plus Px equals to 2. Okay, then here E minus 9.2. When 0, I get 1. When 1, I will just write 9.2. X equals to 2 means that 9.2 squared over 2 factorial. Then now here, you will get 0.00531. This is less than 0.02. Okay, then now Px less equals to 3. Because this is very small, right? So I want to get the critical region. Therefore, I consider x less equals to 3. So when x less equals to 3 is basically Px less equals to 2 plus Px equals to 3. Alright, that's the reason I give more decimal place in the previous calculation. So now here I will just copy 0.00531 plus Px equals to 3 means it is E negative 9.2. Then 9.2 to the power of 3 over 3 factorial. So when you count this value, it's going to be 0.0184. And again, this is less than 0.02. But it is quite close to 0.02. Okay, so now I have to check for next value. So Px less equals to 4. So when Px less equals to 4 is basically Px less equals to 3 plus Px equals to 4. So I will copy the value from previous calculation plus, now for Px equals to 4, again do one calculation. E to the power of negative 9.2 times 9.2 to the power of 4 over 4 factorial. Then here is going to be 0.0486. And this value is greater than 0.02. Means that now we can just accept up to x less equals to 3. So therefore, the critical region is x less equals to 3. Okay, so that's all for this working. Right, now the officer notes that during a randomly chosen 2 minutes period on a weekday morning, exactly 5 cars arrive at the junction, carry out the test. Okay, so now my test will be H0 lambda equals to 9.2, H1 lambda less than 9.2, reject H0, I should write alpha first. Alpha is 0.02, so reject H0 if x less equals to 3. Okay, this is the critical region that we have found in previous step. Now, mention that exactly 5 cars arrive. So given x equals to 5, this value is greater than 3. Alright, so based on the previous rejection criteria, we know that when x less equals to 3, we reject H0. So now you are given 5, which means we do not reject H0. Okay, so do not reject H0. So this is our decision. So when you do not reject H0, means that, again, it does not show it has been reduced. Alright, so there is insufficient evidence to conclude that there are now fewer cars arriving. Alright. So that's the conclusion for the test. Okay, now D. State with a reason whether it is possible that type 1 error has been made in carrying out the test in part C. Okay, now let's look at the definition for type 1 error. So probability of making type 1 error is basically we reject H0 given that H0 is true. Okay, so now when you look at the part C, our conclusion is do not reject H0, right? Whereas your type 1 error means reject H0. So that means this is not possible, right? Because your conclusion is do not reject H0. So now, not possible to have type 1 error. Because now you need to state with a reason. So not possible is the conclusion. What is the reason? Because do not reject H0 in part C. Okay. Now, the number of cars arriving at another junction on a morning has also has Poisson distribution with mean 4.6 per minute. E. Use a suitable approximating distribution to find the probability that more than 300 cars will arrive at this junction in 1 hour. Alright, so now 1 hour has 60 minutes. Therefore now 4.6 times 60. It will be 276. So this value is greater than 15. So when greater than 15, we need to use normal approximation. Okay, so now my y, let's say my y is Poisson distributed with 276, then it will be approximate to normal, which is the normal variable w is n. The mean is 276. Now for your information, for Poisson distribution, x is Poisson, lambda, the mean is lambda, variance also lambda. Okay, therefore for the normal distribution, variance also 276. Now be careful with this. Okay, Poisson is discrete random variable, normal is continuous random variable, and now you need to get more than 300 cars. So py greater than 300. So now for your information, if you approximate the discrete random variable to normal random variable, to continuous random variable, it's compulsory to carry out the continuity correction, which means you have to decide whether you plus 0.5 or minus 0.5 from the given value, which is 300. So let's say here is 300. So now greater than 300, basically your value start from 301, then followed by 302 and so on. So but then now we can plus or minus 0.5 from 300, which means you have two choices, either 299.5 or 300.5. So obviously to include the two ticks, we need to get greater than 300.5. Okay, so we have to choose plus 0.5. That means here is going to be PZ more than 300.5. Then now I will standardize this. So when I standardize this, I will minus this value from the mean. So minus 276 over variance over standard deviation. Okay, this is the formula I'm using. So x is normally distributed, mean mu variance sigma squared. When you standardize it, it will be x minus mu over sigma. Then here is going to be 276. Now, when you count this value, you will be getting PZ more than 1.475. Okay, so when more than 1.475, then I need to draw the graph. Middle is 0. So 1.475 is on the right hand side. And this is greater than. Therefore, the region is towards right side. Now, the normal table always show the region towards the left hand side. Therefore, I have to use 1, which is the total area, minus the region which is less than 1.475. That will be greater than 1.475. Okay, then here is going to be 1 minus b, z less than 1.475. And now read the probability from the table, the normal table. Then you will get 0.9299, and then final answer will be 0.0701. So that's the solution for this part. Okay, now question number 5. A random variable x has probability density function given by this quadratic function, and it is defined for x from 2 to 4, inclusive both. Other x, it will be not defined because fx is 0. Show that ex is 11 over 4. Ex is the expected value of x. So ex is basically integrate x fx dx. Okay, this is the formula. And throughout the given x, the x from 2 to 4. So this is the formula for ex. Now, since there is a 3 over 16 here, this is a constant. I will just take out the constant. Then integrate 2 to 4. My x times the fx, right? So 4x minus x squared dx. Then from here, I will get 3 over 16. Integrate 2 to 4. Now, before we do the integration, we need to multiply the x first. Then I will get 4x squared minus x cubed dx. Okay, then here you will be getting 3 over 16. Now integrate 4x squared, it will be 4x cubed over 3. Then the x degree 3 becomes x degree 4 over 4. Limits 2 to 4. Okay, after that, now you replace the x by 4 first. So I will write 3 over 16, 4 over 3 times 4 power 3, 4 cubed, minus 1 over 4, then 4 to the power 4. Okay, all this minus when the x is 2. So I will get 4 over 3 times 2 cubed minus 1 over 4 times 2 to the power 4. Okay, then from here, when you calculate all this together, you will get 11 over 4. Alright, so with this, we have shown the ex value. Now B, find variance x. So variance x, we need to find ex squared first. So just now ex, now ex squared. Okay, so the difference is the x here, okay, becomes x squared. Just change accordingly, which means I will change this to x squared. So when I change this to x squared, means that this one I just add on 1 degree. Alright, so I will direct jump to this step. So instead of 4x squared, I change to 4x cubed. Then the x cubed at the back change to x degree 4. Alright, so I will get, or probably I will write down the definition first. This is x squared fx dx from 2 to 4. Then I will write this is 3 over 16, integrate 2 to 4. Then now here, right, remember I changed this. So 4x cubed minus x degree 4 dx. Alright, so now we need to integrate. So here 3 over 16. So 4x degree 4 over 4 minus x degree 5 over 5. Limits 2 to 4. Now, the first term 4 over 4 can be cancelled off. So here I will rewrite. Basically, I will get 3 over 16 times x degree 4 minus x degree 5 over 5. Limits from 2 to 4. Okay, then from here I will get 3 over 16 Now replace the x by 4. So 4 to the power 4 minus 4 to the power 5 over 5. Then another minus when the x is 2. So 2 power 4 minus 2 to the power 5 over 5. Okay, so from here, you will be getting 39 over 5. Okay, then now the variance x is basically expected x squared minus square of the expected value in the previous part. Then I will get 39 over 5 minus ex from the previous part, 11 over 4. So now, when you calculate this, you will be getting 19 over 80. So that's the variance x for this question. Okay, now see, given that the median of x is m, find probability that x between m and 3. Okay, so now, since the median is m, okay, so let's look at this diagram. Your fx is defined from 2 to 4. Okay, the median is m. Alright, so the median means from 2 to m, it will be the probability of 0.5. Alright, because the total probability is 1, which is same as the integration throughout the whole interval. Then now you need to find m to 3. Let's say here is 3. How much is this? Okay, so now I will say probability that x between m and 3 is same as probability of 2 to 3, okay, 2 to 3 minus 2 to m, right? Probability of 2 to m is basically 0.5. Now for your information, since this is continuous random variable, equal sign or not equal sign is the same. Alright, so now this is same as b between 2 and 3 minus 0.5. Right, so for the first one, I can just integrate the function directly. So for any probability, you just integrate the function. Alright, so I will start with 2, then after that until 3. So now it will be 3 over 16. I always factorize a constant. 2 to 3. Then 4x minus x squared. This is the function. After that, you minus 0.5. Okay, so here is going to be 3 over 16. You integrate 4x, it will be 2x squared. Right, which is 4x squared over 2. So 4 and 2, you get 2. Then minus x cubed over 3. Limits 2 to 3. Then minus 0.5. Now, replace the x by 3 first. So I will get 3 over 16. 2 times 3 cubed minus 3 cubed over 3. Then all this minus when the x is 2. So 2 times 2 squared minus 2 cubed over 3 and then minus 0.5. Okay, so for the first part, you are getting 11 over 16 and then minus 0.5. So at last, here you will get 3 over 16. So this is your probability of x between m and 3. Even though the m is not given, but then we know that from 2 to m, it will be 0.5 due to this diagram. Okay. Now, question number 6. The masses in kilograms of large and small sacks of grain have the distribution have the normal distribution 53, 11, for the large sacks of grain, and for the small one it will be normally distributed with mean 14 and variance 3. A. Find the probability that the mass of a randomly chosen large sack is greater than 4 times the mass of the randomly chosen small sack. Okay, so now let's say the large is L, normally distributed 53, 11. Then the small is S. So now you need to count probability that the large is greater than 4 times of the small sack. Right? So now from here I need to count what is my expected, or what is my distribution for L minus 4S, because I need to count this probability which is greater than 0. So now my expected value of L minus 4S, okay, so it will be same as expected value of L minus 4 expected value of S. So my L is 53. Okay, EL is 53. This is a mean. This is a variance. So the E is actually the mean. Minus 4 times of 14. Then this will be minus 3. Now, for the variance of L minus 4S, it will be variance L plus 4 squared variance S. I square it because it's 4 times. It is not addition, it is a multiplication. So here becomes 11 plus 4 squared times 3. Then you will be getting 59. Which means now from here I will get L minus 4S is basically normally distributed with mean -3, variance 59. Okay, now I standardize this L minus 4S. So it will be Z more than 0 minus -3 based on this distribution. Then over square root of 59. So this is going to be my Z value. Then now when you calculate that value, it's going to be 0.391. So when it is greater than 0.391, now I need to sketch a normal graph. Here is 0. Let's say this is 0.391. And now it's greater than, that means the region towards right side. So obviously this region is 1 minus all region before that. So it will be 1 minus P Z less than 0.391. Okay, and this probability can be found using table, which is 0.6521. Then at last you will be getting 0.3479, and now I round up to 3 significant figures. It will be 0.348. So this is the solution for this question. Now, next part B. A lift can safely carry a maximum mass of 1000 kilograms. Find the probability that the lift can safely carry 12 randomly chosen large sacks and 25 randomly chosen small sacks. So it means that now, okay, you need to get P 12x plus 25, not x, large, L, plus 25 small, maximum is 1000, means less equals to 1000. Okay, now I need to get this distribution of 12 large plus 25 small. So again, expected 12 large plus 25 S equals to 12 EL plus 25 ES. So now again calculate. EL, expected L is 53, then the other one is 14. So I will get 12 times 53 plus 25 times 14. Then this is going to be 986. So for the variance, 12L plus 25S. So now be careful with this question. This 12L is addition, okay? And then 12 large sacks. So you add. And the 25 is 25 small sacks, means that it's also addition. which means for the variance now, no need to square the 12 and 25. It will be just 12 variance L plus 25 variance S. So variance L from the previous question is 11. The other one is 3. So 11 and 3. I will write here 12 times 11 plus 25 times 3. So it means that you are getting 207. So with this, my distribution for 12L plus 25S is going to be 986 for the mean, and variance is 207. So now with this, I can standardize the variable. It becomes z less equals to 1000 minus 986 over square root of 207. So it is same as p z less than. Okay, I can just ignore the equal sign in the previous calculation, because for discrete random variable, for continuous random variable, equal or not equal doesn't matter. So when you count the value, you will be getting 0.973. Okay, and again, now I need to sketch a graph because of less than. No, I would not say because of less than, because of z. Okay, you have standardized it, therefore you must sketch a graph. So it is a symmetrical graph, and 0.973 is on the right hand side because middle is 0. So now the region is less than. So which means this region is exactly same as the one in the table. Then I will just direct read from the table. Table will give you 0.8348, and now you round up to 3 significant figures, it will be 0.835. So that's the working for this question. Okay, now question 7. X is a random variable with Poisson distributed 2.9. A random sample of 100 values of X is taken. Find the probability that the sample mean is less than 2.88. Right, so now this is Poisson, but then 100X sample mean. Okay, this sample means for this, the mean of this 100X. Right, now for this case, your X is Poisson, but then we are interested to get the sample mean. Okay, so now I will write my sample mean X bar is summation X over 100. Okay, then now my summation X is going to be 100 times X bar. So the X bar here is the mean. Remember, the Poisson X is Poisson distributed lambda. This lambda is the mean and also variance. So now I will say that this is my mean. Okay, then here is going to be here is going to be 100 times 2.90. Then it will be 290. Now, so the summation X is 290. Okay, so which means, okay, it is greater than 15. Then now I need to approximate to normal. Okay, so which means now basically I will get the distribution of the summation X. So my summation X is Poisson 290. Then I will approximate to normal distribution. So now, what is my mean here? So just for information, for any Poisson, mean is same as variance, is same as the lambda, which means now my mean is 290 for the normal distribution. My variance is also 290. Okay, so now I'm getting the distribution of the total X, the summation X. Now, from here, you need to count the probability that the X bar is less than 2.88. So P X bar less than 2.88. So the X bar less than 2.88 is similar to, Okay, let's say here, look at here. X bar is summation x over 100, right? So now we know that summation x is 100 x bar, which means here I will say my summation x is less than 288 because of this concept. Alright? So now when summation x is less than 288, remember here, the previous step, your summation x is Poisson distributed. Because the mean is greater than 15, we approximate to normal. So now from Poisson you change to normal, we need to carry out the continuity correction. Therefore, I will draw a line, mark 288, but then since it's less than 288 means that we will just take 287 or 286, all these values. Okay, and now you are allowed to plus or minus 0.5 from 288, which means I will either get 288.5 or 287.5. So obviously I have to choose 287.5 to include the two ticks. Alright, so now I will standardize this because my W is normally random variable, is the normal distributed. So then Z less than 287.5 minus 290 over square root of 290 because the variance is also 290. Then now when you calculate this value, it's going to be negative 0.147. Okay, then this must be followed by the graph sketching. Middle is 0. So negative 0.147 is on the left hand side. Okay, that's the region. Now obviously we have to reflect the region to the right side. This is 0.147. Now the green region is the reflected region of negative value. So now to get the green region, it will be total probabilities 1 minus all previous probabilities. Alright, so which means now here I will get 1 minus BZ less than 0.147. Then from here, you will just read the probability from the table and it will be 0.5585. Now when you calculate this value, okay, the answer is going to be 0.4415. And now if you need to round up to 3 significant figures, it will be 0.442. So that's the probability of this question. Okay, so we have come to the end of the video. Thanks for watching. If you enjoy watching my video, please subscribe to my channel and share it to your friends. Okay, more videos will be available soon. Thank you. Bye.